starting the 12.2 lecture notes here, and we'll be going over the sun and the moon.
All right, so we have arrived in our solar system now, and so we are going to take a look at two features of our solar system that are very important. The first being what makes our solar system the solar system. Solar comes from the word sol, which refers to sun. So our sun, in the grand scale of things, which we looked at previously, is what you would call, relatively speaking, kind of a medium size. But as we have seen, stars can be ridiculously more massive than our sun. It is technically categorized as what's called a yellow dwarf star. And we use that word dwarf kind of loosely. It's still pretty massive. You can see that from the numbers you can see there. 100 times the Earth's diameter, so pretty big. Key components, though, is that stars, including our sun, are made up of hydrogen gas, right? That's what fuels them. And that hydrogen gas becomes fused together into helium. And that is our process, energy-making process in all stars, including our sun. It is so massive that within our solar system, and that includes all the planets, all the asteroids, all the comets, all the moons, all the other things in our solar system, only make up 0.2%, because the sun's mass makes up almost all the rest, almost 100% of the mass in our solar system, which is pretty crazy. And the sun is about halfway through its life cycle, somewhere around 4.5 to 5 billion years old, and probably another 4 or 5 billion years until it starts to really expand and swell up into that red giant and make its way into its last throes. You can see a lot of vocab here for the sun, lots of different features. There's some nice videos and links that go into showing some of these features, especially with some of the observatory tools that we have and NASA has and other space agencies have. But if we look at this diagram down on the bottom, it gives us a nice synopsis of some of those key terms. Firstly, the sun has what's called a corona, word of the year, right? But the corona is, again, that word means crown, if we don't know that already. And that is kind of this outer atmosphere, this almost halo that we see around the sun. And you can see that the corona is what you would see during like an eclipse, all right? Then you have this inner atmosphere called the chromosphere, all right? And you can see the temperature increase and difference between those two is pretty drastic. But what we see, or what we refer to as the surface of the sun, all right, so looking at this kind of bubbling hot plasma, that's the photosphere, all right? That is what we tend to be able to see. You'll notice on that photosphere, there are these darker spots called sunspots, and they tend to be slightly cooler, but they are high and full of radiation and can release large amounts of radiation from those areas that can do some kind of crazy things to our Earth's, our magnetic field, as well as other planets' magnetic fields. You also have what are called prominences, which are these kind of little, you see one very large right here, these little explosions of plasma, these waves of plasma that kind of bounce out. And then in the center is the core, and that is where all the action is taking place. And let's talk about that action. That action is fusion, which we talked about in our nuclear chemistry unit back in the fall. And fusion basically means that we have two small elements, in this case hydrogen, and we are forcing them together. And that's due to the huge amount of mass and the huge amount of pressure that is present in that core. You can see the temperatures are going to reach ridiculously hot temperatures, all right? Ridiculously hot, both in degrees Celsius and Fahrenheit. We couldn't withstand any of that, nor could any of our equipment. That's why we don't send things inside of stars. Why is this important? Well, that fusion, that energy, that heat, that radiation is what allows us to have life on Earth. We are at a location in our solar system where we get enough of that sun radiation to provide us with heat and energy for life, but also not too much or not too little that we can still have liquid water, right? All the water doesn't evaporate up, and it is not too far that it is frozen. And that is a key feature to why we have life on our planet. One of the really awesome features of the sun, though, is that because it is constantly spewing out this radiation in high levels, this radiation tends to interact with different chemicals that we have in our own atmosphere in some interesting ways. And by kind of electrifying or exciting the energy particles, specifically in oxygen and nitrogen, we end up with these beautiful light shows on the north, near the North Pole and near the South Pole, called the auroras. All right. The aurora borealis, probably the more familiar of the two, are the northern lights that we see anywhere close to the North Pole. So places like Norway and Greenland, sometimes even the north of Scotland, northern Russia, etc. And then you have Australis, which would be in the south, obviously Antarctica, Australia, etc. You can see them. And again, we get the different colors based on the different atmospheric molecules, oxygen or nitrogen, that are being interacted with by this electromagnetic radiation coming from the sun. So not only gives us life and heat, but gives us a pretty cool light show as well.
All right, so the forming of the moon was about 4.5 billion years ago. And this occurred when the protoplanet collided with early Earth, and that resulted in some debris happening and being thrown around, and this caused our moon to now orbit our Earth. There have been missions to the moon. Some of those missions are listed here. And then we also have some pictures on here as well of some of the spacecraft, some things Ms. Laporte has seen as she has visited, I believe it was Kennedy Space Station, right? And then I also have some history there with that plaque from my grandpa. He did some steel polishing for some of the rovers that are up there on the moon as well. I'm sure the ones you're most familiar with are probably the Apollo missions, which they went to the moon, and the first moon landing of Apollo 11, and then Apollo 13 as well, being one that was called a successful failure.
Check out those links. They give you some cool information about some of these missions. You get some footage from that first moon landing, which is pretty awesome. That was the first time, obviously, ever that a human stepped foot on something land-wise that was not Earth. So that's pretty amazing. And and the ingenuity from Apollo 13, if you have questions on that, we can talk in class. It definitely was a scary moment. Anytime there's a potential or actual loss of life in the space program, it's a big concern. But the ingenuity of the people on the ground and the 3 men in the Apollo 13 spacecraft to be able to get them home safely was pretty impressive. So definitely check out those additional links as well.
All right, so some facts about our moon. It is a natural satellite, so it does orbit our Earth. It is the only other spot in our solar system that humans have actually physically visited, like Ms. Laporte has said. So it's the only place somebody else has landed on and actually stepped foot on. So that's pretty interesting. I know sometimes people think there are other things in other places, but it's only been the moon. And that moon stays in orbit with Earth because of the gravitational relationship between the Earth and the moon. So that force is what's keeping us kind of together.
And remember, when you go on the moon, the gravity there is significantly less. All right. You saw that. I'm just going to pop back real quick. In terms of relative sizes, the Earth's mass is much bigger, hence a larger gravity, 9.8, right? The moon's mass is much smaller, hence a much lower gravitational pull. It's only about 1.6 or a little bit over that. And the reason, like Ms. Kay said, that the moon stays satellite or as a satellite or orbiting the Earth has to do with that original collision and the momentum and inertia, right? That moon started moving in that direction, and there's no other force really to knock it out of that movement. And so the moon kind of stays doing what it does because of, again, that initial inertia following that creation and collision between those two protoplanets, resulting in what we have today.
And I love that lower picture on that page. So cool to me.
Yep, on the moon, taking a peek at the Earth. Yeah, there's a lot of really great shots out there. And I mean, I think this, view, the top picture as well, just gives you a nice view of a lot of things Miss Case is going to talk about next in terms of some of the features that we see on the moon too.
Yep, so just like the sun having a lot of some vocabulary, we also have that here with our moon. So we've got craters, highlands, and Marias, and they are all something different. So we've got our craters, which is something you're probably more familiar with, right? Those pits that are on the surface of the moon from the result of meteors impacting it and colliding with the moon. Those highlands are more of elevation areas. Those are normally represented in lighter colors. Then our last one is Marias, and those are our low elevation. So this is where it had been flooded with molten lava billions of years ago. And the one that you see there is the Sea of Rains. That's one that you could see visible with a telescope. And we do have some additional pictures that I have from my dad who took them. So if you're interested in seeing them, let me know and I can share those with you. And then we have our lunar cycle of the moon. So this is the phases of the moon. The moon orbits in a counterclockwise direction, which I think is different than what most people think. So it's going, around this way, like Miss Laporte is going there. It's going opposite than the clock, right? Counterclockwise. And the complete cycle for the moon is 29.5 days.
And while we're not going to require you to know the different phases, it's always kind of, it's cool party trivia to be able to understand, the reason why the moon is going to appear either kind of new or darkened versus full and brightened. The moon doesn't have any of its own radiating light, right? It is a satellite rock that orbits the Earth. It is the reflection of sunlight that results in that, or the blocking of sunlight. And so obviously a new moon kind of sits between where the sunlight is coming in and our planet. And then as it moves around during that almost month's time, it will have crescent shapes because some of the moon will be in a position to reflect light. And we call that waxing when we start to see the light. Then we have these quarter moons, which really is a half. And then we get to kind of halfway through the cycle and it is full. So the whole moon then is able to reflect that light, or I should say the whole side of the moon that we see reflects that light. And then they're called gibbuses when they have more than half being lit up. And then again, we kind of finish out with those crescents again. Just know that for a variety of reasons that we can talk about if you would like to know more, we only see one side of the moon all the time. No matter what phase it's in, no matter what time of month, we are always looking at the same side of the moon every single time we look at it, which is another kind of interesting fact.
All right, and then we have eclipses. So we have solar eclipse and the lunar eclipse. You know the difference between these two. We've got the solar, where the sun, then the moon, and then the earth. And this is where the moon shadow is on the earth. So this can be either a total solar eclipse, which is more rare, or a partial eclipse. And then we have our lunar eclipse, which is our sun, then the earth, and then the moon. And this is where our Earth's shadow is on the moon, right? And the moon appears more reddish due to that light that's being scattered by our atmosphere here on Earth.
Typically, you can see them best at different parts of the globe when they happen, because again, it all has to do with alignment. So sometimes the solar eclipse can only be viewed from certain other countries or places. And yes, within the last few years, there was an eclipse that you were able to see in our neck of the woods. So a lot of people were out and about going around the country to be able to get in good spots to see it.